Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, so how do we actually calculate concentration? So the easiest way to do this, I think, is to think about the units of concentration, and that is grams per decimeter cubed. Now, either you can write that as G dm to the -3 or G slash dm to the 3. Both of those are identical. And when we say per, we literally mean grams divided by decimeter cubed. So that gives you a clue as to what you have to do. You have to take the mass and you have to divide it by the volume, and that will give you your concentration. If you like a triangle, by all means learn this triangle: mass on the top, concentration and volume on the bottom, and you just need to make sure that all of those units are matching. So mass in grams, concentration in grams per decimeter cubed, volume in decimeters cubed. You might have to convert your volumes, so you should know that there are 1,000 centimeters cubed in 1 decimeter cubed, and therefore if you needed to get from a volume that they'd given you in centimeters cubed to decimeters cubed, divide it by 1,000 first before you maybe tried to plug it into this equation to work out a concentration in grams per decimeter cubed. So just look out for those units. Make sure that everything's matching before you plug it into this equation. Okay, how do we convert between mass and moles, and what about concentration in grams per decimeter cubed and concentration in moles per decimeter cubed? So you should know from our previous topic, in order to go from a mass in grams into the number of moles, you are dividing through by your relative formula mass, and if you want to go the other way, you multiply by your relative formula mass. Concentration is exactly the same. So concentration in grams per decimeter cubed to concentration in moles per decimeter cubed, you do the same thing. You divide through by the relative formula mass, or if you want to go the other way, you multiply by your relative formula mass. And that makes sense because really, if you think about it, if I have a certain concentration that's quoted to me in a number of grams per some volume, and I want to know how many moles that is per the same volume, then why would I not do the same thing that I have to do to get from mass into moles? Just to add in here as well, remember when you're going from mass into concentration, you're dividing by the volume, or concentration to mass, you're multiplying the volume, and it's exactly the same whether the concentration is quoted in grams per decimeter cubed or moles per decimeter cubed. Okay. Easiest with an example. So how many grams of hydrochloric acid are there in 45 centimeters cubed of something, a HL solution that has this concentration of 0.5 moles per decimeter cubed? First thing I'm noticing here is I'm going to need my concentration and my volume to be in the same units. And at the minute, I've got moles per decimeters cubed for my concentration and centimeters cubed for my volume. So I need to change that volume so that it's in decimeters cubed. And from our previous slide, you need to know that in order to do that, you need to divide by 1,000 to get from centimeters cubed to decimeters cubed. So let's do that. 45 divided by 1,000 is 0.045 decimeters cubed. Okay, my next step here is to notice that this is currently my concentration is in moles per decimeter cubed. So then I need to remember, how do I get from that into grams per decimeters cubed? I want that to be in grams per decimeters cubed because eventually that's what I'm trying to work out. I'm trying to work out a mass. So I want my concentration to be in that unit, gram per decimeters cubed. And how I do it, if I look above, is I just multiply by the relative formula mass of, well, whatever the thing is, and here it happens to be hydrochloric acid, and it's given to me as 36.5. So 0.5 moles per decimeters cubed times 36.5 is 18.25. And then my final step here is I wanted my mass in grams, and I've got a concentration and I've got a volume. So I multiply those two things together, 18.25 my concentration times 0.045 my volume gives me my mass there in grams, 0.821 grams. Titration at 25 centimeters cubed volume of 0.2 moles per decimeters cubed of sodium hydroxide requires 25 centimeters cubed of sulfuric acid for neutralization. Calculate the concentration of sulfuric acid in moles per decimeter cubed. So first off, let's get our equation up here. So we've got sodium hydroxide plus sulfuric acid. What's that going to give us? Well, we have got a acid and a base. So we've got bores as our mnemonic. Base and acid gives us a water and salt. And the salt that you're going to get is sodium sulfate, okay? And we've got to remember our ionic bonding rules to balance those. Our sulfate ions have a -2 charge. They're a complex ion we needed to learn. Sodium ions have a +1 charge because they are a group 1 metal. So we need 2 sodium ions for every 1 sulfate ion, so we've got +2, -2 with our charges. Now we need to balance it, so I put a 2 in front of my sodium hydroxide there because on my right hand side I had, for example, 2 sodium, but I only had 1 on my left. So now if I check everything, I have got those 2 sodium, but my hydrogen, I've got 1, 2 come from sodium hydroxide, 3, 4 from my sulfuric acid, but I only had 2 from my water on my right hand side, so I put a 2 in front of my H2O. Now if I were to count everything else up, it would be balanced. So I can make my table now for concentration, volume, moles ratio. So what information I've been given? I've been given my concentration of my sodium hydroxide. I've been given the ratio. Well, I haven't been given the ratio. I've now come up with the ratio that for your sodium hydroxide, so sulfuric acid, you have 2 moles of sodium hydroxide for 1 mole of sulfuric acid. Remember, that was the point in even writing this equation out and balancing it in the first place. And then to work out the volume, remember I can take my volume in centimeters cubed, divide it by 1,000 to get that volume in decimeters cubed. And the reason I'm doing that is because my concentration is in decimeters cubed, so I need them to be in the same unit. And same for my volume of my sulfuric acid, it's in centimeters cubed, but let's get it into decimeters cubed by dividing by 1,000. Then to get my number of moles, I take my 0.2 concentration, multiply it by the volume, 0.005 moles of sodium hydroxide, and then I'm in this ratio of 2 to 1. So if I take 0.005 and divide by that 2 there, I will get 0.0025. So see how that number of moles is still in the same ratio, 2 to 1. So there's double the number of moles of sodium hydroxide to sulfuric acid. Now I can work back up and I can get my concentration that I need of my sulfuric acid because I have got my number of moles divided by my volume gives me that concentration, 0.1 moles per decimeter cubed.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets and completely for free, so why not?
The first tip and trick here is be careful with your unit conversion. So yeah, as I've mentioned in previous slides, if you've got a volume in centimeters cubed but a concentration in like grams per decimeter cubed, make sure that you change your volume into decimeters cubed first. Also be careful with grams and kilograms. You need your masses in grams if you're going to use relative formula mass to identify the number of moles. And also you probably need your masses in grams anyway. If you're looking at concentrations, they're quoted as grams per decimeter cubed, so you make sure you've got your masses there too. 2 ways to go with concentration conversions. Feel free to use either way, whatever feels best to you. They're both fine. And the final thing is careful not to get confused. Sorry, get the titration tables if you are on a spec that does the titration one, confused with the reacting mass tables. You need to know to multiply to the third row, okay? So they work slightly differently, those two tables. We have the same kind of U-bend thing, but just be careful of that as well.